Everybody has a job, and you might think that your job is not important, but when your job is a part of a system, then it means a lot. It's like a clock. When a part does not work, it claps immediately. There is no difference between our computers and a clock. It made of plastic and metals and does some certain tasks. The concept of our computer was published by John von Neumann in 1945. The concept was a machine that could solve problems, and how the machine worked should not depend on the problem. In von Neumann's architecture, a computer consists of 4 parts, and each part has a task. The first part is RAM, or Random Access Memory. As the name suggests the functionality, this part stores the data and a program. Random access memory is made by cells. Each cell can store an amount of data and has an address, which allows us to call this address and read and write the data in these cells. Beside the CPU that you have, the RAM plays a big role in multitasking. The more memory you have on your RAM is better for multitasking, because you can store more data and programs on it. But this memory is not the same memory in which you store your data like your picture on it. When you shut your PC or your phone down, all the data which are in RAM will be disappeared. And when you want to run an app that is in your long-term storage drive, the computer's operating system loads the data from the drive into RAM to process it. And when you want to save something in your drive, the data will go through the RAM. So why do we use RAM in the first place? Could not our CPU communicate directly with the long-term storage? RAM is significantly faster than your hard drive disk or your solid-state drive. That means the CPU can load and process the data faster, which allows you to run your app so smoothly. Another storage that helps your computer process faster is caches. Caches can store less data than RAM, but because they are closer than RAM to the CPU, they can communicate with the CPU faster. Since caches have significantly less memory space than RAM, they only store the data that might be needed later. The CPU or Central Processing Unit contains 2 other parts. The first part is Arithmetical and Logical Unit or ALLO, and the second one is the Control Unit. The ALLO allows arithmetical and logical operation to be carried out. These operations are such as addition, subtraction, multiplication, not, and etc. And that is exactly what our computer does. Let's have an example. An image is made from many pixels. A pixel is made from 3 colors. These colors are red, green, and blue. Every color has a value of intensity, and these values are mostly in your long-term storage. When you want to open the image, these values will be loaded into the RAM. The data of every pixel is stored in a cell, and all we know is their starting address. So the ALLO will calculate the position of every pixel, and then it calculates the value of intensity of every color. If you want to edit your picture, the ALLO will do the same process again and again. The ALLO has its own space to store the data, and there are registers. Every register has a name, and they all can store the same amount of data. In the 80s, a register could store 32-bit, and a CPU chip had only a few registers. An example is the Intel i386 processor, which had only 8 registers, and every register could store 32-bit. The main reason why we use registers is that they are faster than caches. And beside that, most of the time you need the result of your calculation again and again. So if you store the result in the caches or RAMs, your CPU needs a lot of time to load it again. The control unit is the third part, and it controls everything. Every program is made by commands, and each command will be executed one after another. The control unit controls the ALLO, and will decode and execute every command. It also controls the data transfer, and moves the data from one part to another. The ALLO can only calculate things. You should give the ALLO the operand and the operator, otherwise it can do anything. Some commands in the program contains the operand and the operator. First, the control unit will load the command, and after that it tries to see what this command means. This command sometimes contains the operand, and sometimes it contains the address of the operand, which is an address in RAM or register. Due to the command, the control unit will load the operand from RAM or register, and will give it to the ALLO. After that calculation is done, the control unit will take the result and will store it into the RAM or register. So the last part that we didn't talk about is the output and input devices. These devices could be our monitor, printer, keyboard, long-term storage, and etc. If the computer was a factory, the data which we see in output devices are the products, the programs is the production method, and the input devices are the resources. In this factory, everybody has a job, and when a part does not work, the whole factory faces a big problem. A computer is a complex machine, so say with electrons where we try to explain the logic behind our computers with a simple language. Please subscribe to the channel, and if you like it, then like it.